Hello, Algebra 1 students. Today we are going to talk about quadratic trinomial factoring with a GCF. Last week we worked on quadratic trinomial factoring, just the process and how it works. This week we're going to add in that GCF and then continue to factor to make sure we can see how taking a GCF out is important to make sure our final answer should always be completely factored as far as we can factor it. So our question for today is, how can we start the factoring process using a GCF? Right, so that's what we're going to focus on and should be able to answer by the end of these notes. Remember, you should be watching this from the Play Pause It on Canvas, so you're answering the questions as you go, as opposed to just watching in notes and taking them down. You need to answer the questions in order to get credit for the notes for this week. All right, so here we go. The beginning here says, as stated in step 2 of quadratic trinomial factoring, if the trinomial has a GCF, it should be factored out. And I want us to put the word first in here. Step 2 is to factor out that quadratic first. So we want to be factoring it out. That is going to help us immensely when we're doing this work. So here we are. With number 1. So number 1 here, I'm going to move it up my page a little bit, so it's at the top of the page. All right, we have 18x squared plus 33x minus 30. Now I'm going to show us how to find that GCF one time today. I'm not going to keep showing us, so if you see the GCF, you don't have to keep doing the columns. But if you don't see a GCF, then you need to start by trying to find the GCF, right? So if I look at the number 18, the number 33, and the number 30, right? We're going to try to find the factors of 18, 33, and 30. So I have 1 times 18. I have 2 times 9. I have 3 times 6. Those are the 18 factors. For 33, I have 1 times 33, and I have 3 times 11. And then 30, I have 1 times 30. I have 2 times 15. I have 3 times 10. 4 does not go into 30, and then I have 5 times 16, right? So these are the columns. If you needed to write these out, trying to find a GCF, feel free to do that. If I'm looking now for my GCF, I have a 1 in these guys, and then 2 does not go into 33, so that doesn't work. 3 goes into all 3 columns, and those are the only 2 numbers that they have in common. So my GCF for this problem is 3. So we're going to start by dividing out that 3 from all 3 terms, right? So 3 comes on the outside. I'm going to move it down a second. Let me move this down just a little bit first, so I have room for the math coming up. All right, so 3 times 18 divided by 3 is 6. So we have 6x squared. 33 divided by 3 is 11, so 11x. And negative 30 divided by 3 is negative 10. So here we are. We took the 3 out. Now we have 6x squared plus 11x minus 10. At this point now, we have a quadratic. It is 3 terms in that parentheses. Now we can do the factoring piece of this, right? So I'm going to change to blue here, right? So I'm going to box that middle term. If you remember from last week, right? We're going to grab the 6 and we're going to grab the negative 10. 6 times negative 10 is negative 60, right? So we're going to take that negative 60 and we're going to find the factor pairs of negative 60. And then since it's a negative number, they're going to subtract to the number that's in our box, which is a positive 11x. Since we're subtracting and we need to get a positive 11x, that means the bigger number is positive, right? They're going to have opposite signs. The bigger one's going to be positive because we need it to be positive 11x. That's what we're separating. So I'm going to do my factor pairs now. So we have 1 times 60, 2 times 30, 3 times 20, 4 times 15. I apologize for my dog in the background. 5 times 12, and 6 times 10. 1, 2, 3, 4, 5, 6. I'll go into 60. 7 does not, 8 does not, 9 does not, and then we're back at 10. So those are all my factor pairs. I need to find the ones that subtract and give us 11. So if I look at the first one, 60 minus 1 is 59. That does not work. I look at the second one, 30 minus 2 is 28. That does not give me 11. I look at the third one, 20 minus 3 is 17, not 11. Look at the fourth one, 15 minus 4, yay, it is 11. So I am going to, I'll change that to red right now, right? There we go. And the 4 is going to be negative because it has to be a positive 11x. So here we go. I'm going to take my 6x squared. I'm going to put it out here. and then I'm going to put minus 4x plus 15x minus 10, right? That is taking that 11x and splitting it into negative 4x plus 15x. That's how we factor quadratic trinomials. And then I'm going to put down my wall, right? The first two are going to be split from the second two, and we're going to do a GCF in the first two. So 6 and 4 have GCF is 2, x squared and x, the GCF is x. So 2x comes out, and then 6 divided by 2 is 3, x squared divided by x is x, negative 4 divided by 2 is negative 2, right? X divided by x is 1. So I have 2x times 3x minus 2. And then the second two numbers, we take a GCF out. So 15 and 10, I can divide 5 out of both of those. 5 comes out front. 15 divided by 5 is 3 times that x. Negative 10 divided by 5 is negative 2, right? This was the quadratic trinomial factoring from last week. You're going to get lots of practice this week on it on your homework. All right, so these two are exactly the same, right? So that's 3x minus 2. We take the first two terms, we put those together, right? So that's 2x plus 5 because it's positive. And then we need to remember this guy up here, right? This 3 out front needs to be part of our final factored answer. So our final answer here is 3 times 3x minus 2 times 2x plus 5. Right? So we need, so I'm going to make a note of that over here. I'm going to put an asterisk and say, don't forget GCF in final answer. Right? Super important. So when you factor out that GCF at the beginning, it needs to go. Factored form is every single thing you can factor out needs to all be a part of the answer at the end. That's what factored form is. So the factors are 3x minus 2, and 2x plus 5. It has 3 different factors. 2 of them are binomials. 1 of them is just a constant number. All right, number 2. Number 2 says 14x plus 30x squared minus 8. Now, I don't know how many of you might remember, but the step 1 for solving a quadratic, let me go ahead and move this one up here a little bit. Step 1 for solving a quadratic trinomial, or step 1 for factoring in general, any factoring, is to put it into standard form first, right? So I'm going to make a note of that real quick. Step 1 is that it needs to be in standard form before you start factoring, right? Because we can't do quadratic trinomial factoring if it's not in standard form, and it's just a good practice. So if I look at this problem, I have 14x plus 30x squared. The x squared term has to come before the x, right? You put it from the biggest exponent to the smallest exponent. So I'm going to change this around, and I'm going to have 30x squared plus 14x minus 8. Right, now that it's in standard form, now we can go to step 2 and say, do we have a GCF? And if I look at this, I have 30, 14, and 8. I immediately see I can take a 2 out. So I'm going to take that 2 out. Right, I'm not even going to do the columns. I can see they're all even. So I'm going to take 2 out. I have 2 out here. 30 divided by 2 is 15, x squared. 14 divided by 2 is 7 times x. Negative 8 divided by 2 is negative 4. And then I look and say, okay, 15, 7, 4. Those do not have any GCF in common other than 1, so we're good. So now at this point, now we can do our quadratic trinomial factoring, right? Box the 7x in the middle. Grab the 14, grab the negative 4. Not the 14, the 15. 15 times negative 4 is negative 60. So I'm going to take negative 60, and again it's negative, so we're going to subtract again. We're subtracting 2 positive 7x. So again, this one also, the bigger number is going to be positive, just like number 1 above. And it's also 60, so we already have them above. I'm going to write them again just here. We already did them previously. So 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. If you're doing work, you don't have to keep writing them if you already have it. If you can see the numbers somewhere else, we only write out the list to help us find the answer. If you see the answer right away, you don't necessarily need to write out the entire list. Let's take a look here. So I'm going to change back to black right now. So I need to subtract the 7x. So 12 minus 5 is 7. Right? So that means I have 15x squared minus 5x plus 12x minus 4. And then I'm going to draw my wall down here. Right, we're going to take a GCF out now of the first two. So my GCF of the first two, I'm going to divide a 5 and an x out. So 5x comes out front. 15 divided by 5 is 3. X squared divided by x is x. Negative 5 divided by negative 5 is negative 1. All right, so 3x minus 1. And then over here, 12x and 4, I can divide 4 out of both of these guys. So I have 4 times 12 divided by 4 is 3 times that x. 4 divided by 4 is 1, so minus 1. Right, so my answer, I'm going to move this over a little bit so I can put the answer over here. Right, so my answer here, I'll write my answer in red. So my factors are 5x plus 4 times 3x minus 1. And then the GCF we took out at the beginning, the way beginning here, was the number 2. So this is my final answer, 2 times 5x plus 4 times 3x minus 1, right? Because here's our 3x minus 1. And there were, move it back over again so we can see that, right? We had 3x minus 1 here, and we had 3x minus 1 there. And then we had the 5x here, and we had a positive 4. So 5x plus 4 times 3x minus 1 times that 2 that we took out at the beginning. All right, so that is factoring quadratic trinomials with a GCF. Now let's look at this problem down here. We're going to do a few of these together. So number 3 down here. So we should be starting with checking to see if there's a GCF. So I have, we're checking to see if it's a standard form. Check that first, right? We have y3, y2, y. So yes, it is in standard form from biggest exponent to smallest. Then I'm going to look for GCF. I have 4, 14, 6, and I have y3, y2, and y. So we have y's in all of them, so I can definitely take a y out. And then I also see they're all even. So I'm going to divide out a 2y from all of these. Right? So I have 2y on the outside. 4 divided by 2 is 2. Y3 divided by y is y squared. 14 divided by 2 is 7. Y squared divided by y is y. 6 divided by 2 is 3. Y divided by y is 1. So now I have 2y squared plus 7y plus 3 on the inside of the parentheses. Right? That is a quadratic trinomial. So if it's a quadratic trinomial, we can do the quadratic trinomial factoring, right? Box that middle term. Pull the 2 and the 3 together. 2 times 3 is 6, so that's a positive 6. Go over and do factor pairs of 6, right? If it's positive, that means we're going to add to what's in the box, positive 7y. That means that both numbers are positive, right? Because they both have to be positive since we're adding, and it's got a positive 7y. So I have 1 times 6 and 2 times 3. These are easy little factor pairs. If I look here, and I'm trying to find the one that are the answers, then we need to add up to 7. 1 plus 6 is 7. So that's how we're going to split this 7y. So I have 2y squared plus 1y plus 6y plus 3. Draw my wall down the middle. Take out a GCF out of the first two. The only thing I can divide out is a y, right? Because 2 and 1, the only thing they have in common is a 1. So I have y out front. And you can think of it as a 1y if it helps you, right? Because 2 divided by 1 is 1, y squared divided by y is y, 1 divided by 1 is 1, y divided by y is 1. So I have y times y plus 1. And then here, I have 6y and 3. I can divide 3 out of both. So 3 comes out. 6 divided by 3 is 2. Oh my goodness, Mrs. Kim, look what I did wrong. Let's go back over, let's finish this first. So 6 divided by 3 is 2, and then y. And then 3 divided by 3 is positive 1. All right, so let's go back. Look at this. These don't match. 1y plus 1 and 2y plus 1. So I go back over and I looked at my first two terms. And what is 2 divided by 1? 2 divided by 1 is not 1. 2 divided by 1 is 2. Let's make that a 2. So checking your work is the first thing you should do if those two, if these do not match, right? Those should match because we are factoring by grouping. We are picking the numbers with this process over here to make factor by grouping work. And so now I have 2y plus 1 and 2y plus 1. So my answer is 2y plus 1 times y plus 3. And then we can't forget this guy out front over here, right? This guy needs to be added to the beginning. times 2y. So my factored form for this polynomial is 2y times 2y plus 1 times y plus 3. All right, so you can't forget that first GCF we took out. And then we have the two binomials from the factoring. Okay. All right, we're going to flip the page now to page 18. We have one more problem to do, and then we're going to look at something I want you guys to make sure you've looked at. So let's go to the next page. Here we are. So going up here at the top, I'm going to move this over. So we have 4x squared plus 14x plus 20, right? So we're starting, is it in standard form? So I have x squared, x, no variable. We're in standard form. Next, we're going to check for a GCF. So if I look here for a GCF, I see 4, 14, 20. They're all even. So I'm going to divide a 2 out, and then we'll see what happens. So I'm going to take a 2 out of all these guys. 2 goes out front. 4 divided by 2 is 2 times that x squared. 14 divided by 2 is 7 times that x. 20 divided by 2 is 10. All right, so it looks like that was my GCF because 2x squared, 2, 7, and 10 don't have any other GCFs that can come out. So next we're going to quadratic trinomial factor this because it is a quadratic trinomial. So I'm going to box this middle term. I'm going to pull the 2 and the 10, which gives me a positive 20. All right, we're going to try to split that positive 20. So I'm going to take positive 20 over here. Because it's positive, we need to add to positive 7x. That's our goal, right? We're adding because it's a positive 20, and it needs to get to 7x because that's what we're splitting apart. So I do 1 times 20. I do 2 times 10. 3 does not go into 20. I do 4 times 5, and that is all my factor pairs. Now, if I look at this and I check, 1 plus 20 is 21, not 7. 2 plus 10 is 12, not 7. 4 plus 5 is 9, not 7, right? None of these work. Right? If none of these work, then that means that the quadratic trinomial is a prime quadratic. So if you were asked to factor the original polynomial, which said 4x squared plus 14x plus 20, the only thing that can factor out of this is the GCF of 2. So your final answer would be 2 times 2x squared plus 7x plus 10. Factored form, you got to take that 2 out. But we can't factor the quadratic trinomial because the quadratic trinomial itself is prime, right? So remember we talked about prime last week too. So when you're factoring, you start at the beginning, make sure it's in standard form, factor out GCFs, as many as you can take out, and then if it's a quadratic trinomial, do the quadratic trinomial factoring as well. And then if it's not quadratic trinomial, then you're not doing this process. This process is only for quadratic trinomial polynomials, right? If this was a power of 3 or power of 8 or power of 10 at the first number, then we'd be done. We can't do anything additional. If you remember, we started off a GCF factoring at the beginning of last week. We were just taking out GCF and that was it. We were finished. If it's a quadratic trinomial, then we can keep factoring with this quadratic trinomial factoring process. All right, last thing we have down here is if you find an answer of 2x plus 8 times 3x minus 1, why is it not fully factored, right? So if you're looking at this problem, if you gave me this as an answer for a factor problem, I would tell you you're not done. It's not factored all the way. You need to factor as far as you can go. And it's because if we look here at the 2x plus 8, the 2x plus 8 has a GCF, right? There is a GCF, right? 2 and 8 have 2 in common. So there is a GCF of 2 for 2x plus 8, right? And then if we look, and just to emphasize here, we could put in parentheses here, 3x minus 1 is already simplified, right? This one's already, let me move this over just a little bit so I can finish writing this word. Simplified. So I put the D in there. There we go. Can't fit the parentheses though. Pretend there's parentheses there. All right, so 2x plus 8 has a GCF that can come out. If it has a GCF that can come out, you need to finish the problem. So it says finish factoring here. So if I wrote down, here we go. I'm gonna write it down again. So 2x plus 8 times 3x minus 1 here. Then we're going to take and we're going to factor out the GCF from the first binomial. So that means I'm going to take a 2 out of here, just like when we were doing the in the factoring, the quadratic trinomial factoring, right? When we have the 2 binomials and the 2 binomials split by that wall. These are already in parentheses, but we're just taking the 2 out of the first one. So I have 2 on the outside. 2 divided by 2 is 1 times that x. 8 divided by 2 is 4. And then 3x minus 4 is already simplified, doesn't have anything to be factored. All right, so my final answer is 2 times x plus 4 times 3x minus 1. You can put 1x plus 4 or just x plus 4 either way. And so that's our final answer. So I'm going to move this over. Let's make a note about this final answer here, because this is an important concept to make sure that we have down here, that we need to always look. So always look at what you think is your final factored answer. And you know what, you can even cross this part off because we're not doing this last problem. This is, remember, the area perimeter we took out of this unit because we're in distance learning. So if you want to just put a line through there so you don't get confused. So we're always look at what you think is your final factored answer. Always, always. I'm going to underline that. If you see a GCF, if you see a GCF, factor it out. All right, this shows up. Put a happy face, yay. This shows up if you forgot to take a GCF out at the beginning. You will be able to do the quadratic trinomial factoring. It's going to be bigger numbers. You'll have more factor pairs to look through. But when you get to your final answer, your GCF still is going to be in one or both of your binomials, and you need to take it out. In our notes, our next set of notes, we'll have a couple of examples of this as well. All right, so that is adding in that GCF to quadratic trinomial factoring, right? We got to take a GCF out first. And then once we take our GCF out, if there is one, then we check to see, is it a quadratic trinomial? Is it a power of 2, 3-term polynomial? If it is, then you're going to do the quadratic trinomial factoring, where I've been making a little robot, I call my robot guy, right? With my body and his head, with the number and his arms and his legs. But it's called factor by grouping. The mathematical term is factor by grouping. You're going to factor by grouping and get the binomials, right? And then if you took a GCF out, don't forget to put it out front. All right, so go ahead, and we are done with this set of notes. We have one more set for this week. Actually, I know we said we're done, but real quick, I just want to make sure it's very clear, and I'm going to go ahead and cross it off right now. Go ahead and cross off number 5, right? No area perimeter problems. We already took them off the other ones, but go ahead and cross it off so you just don't forget. All right, we crossed off part of it in there, but I just want to make sure it is very clear. All right, now for sure, we're done. Bye.